everyone, and welcome back to our channel. In today's video, we are going to explore the mind-boggling controversial theory that the universe is a hologram. Now, this concept might sound like something ludicrously bold, likely seen in a science fiction movie, but it's a real scientific theory that some experts believe could be true. And today, we're going to dive deep into what it means and how it could potentially change our perspective of the universe as we know it. So what is a hologram? Well, it is a three-dimensional image, a three-dimensional space created by the interference of light beams from a laser or other coherent light source. When you look at a hologram, you can tilt the image and see the orientation of the shape move. It's as if you see the object in the image from a different angle. It appears to have an illusion of depth and dimension, even though it's just a flat image. This idea is based on a concept called the holographic principle, which was first proposed in the 1990s by physicist Gerard T. Hooft and later developed by Leonard Susskind. According to the holographic principle, the three-dimensional world, the universe comprises galaxies, stars, planets, houses, and people is an image of reality coded on a distant two-dimensional surface. To easily understand the concept, an analogy that is often used to explain the holographic principle is the concept of a 2D hologram on a credit card. If you look at a credit card hologram under a magnifying glass, you will see that it is a flat, two-dimensional surface with intricate patterns and shapes. However, when you shine a light on it, a three-dimensional image appears to pop out of the card with depth, parallax, and other visual effects. Similarly, the holographic principle suggests that the information about the three-dimensional world that we perceive could actually be encoded on a two-dimensional surface, much like a hologram on a credit card. This means that everything we experience in our three-dimensional universe, from matter to energy, could be understood as a projection of information that exists on the boundary of our universe. In other words, the holographic principle proposes that our three-dimensional universe may be like a hologram, where all the information necessary to describe it can be represented as a two-dimensional surface. This surface is known as the holographic boundary, or the cosmic horizon, and it is thought to exist at the edge of the observable universe. Now, scientists are suggesting that our vast and complex universe could be like a hologram, with all the information contained on a two-dimensional surface rather than in three dimensions. So what does this mean for our understanding of the universe? Well, it could help to reconcile some of the apparent inconsistencies between general relativity, which describes gravity on a large scale, and quantum mechanics, which describes the behavior of particles on a very small scale. It could also provide a framework for understanding the nature of black holes, which are known to contain an immense amount of information within their event horizons. This theory has the potential to revolutionize our deep understanding of physics. It suggests that some of the fundamental assumptions of modern physics may need to be re-evaluated. For example, the holographic principle challenges the notion of locality in physics, which suggests that particles can only interact with other particles that are physically close to them. If the universe is a hologram, then information could be transmitted instantaneously across vast distances without any physical connection between particles. Hence, in the holographic principle, the paradox of the contradicting statements on the principle that matter can neither be created nor destroyed is solved, since nothing is crashed out of existence when things fall into the black hole. Instead, it is somehow captured in a preserved image at the horizon itself. So, if the information is not lost in space, it is not lost inside because they are equivalent. The information contained in the matter is smeared across the black hole's boundary. As an analogy, think of very important documents that are fed through the shredder. Even though they are cut into tiny pieces, the details and information are completely unchanged and intact. It's cut into tiny pieces, but no information is lost. In essence, the same thing was thought to be true with the particles in the black hole. When an object gets pulled into the black hole, it leaves behind all information, some sort of 2D imprint encoded on the event horizon. Later, when radiation leaves the black hole, it picks up the imprint of this data. In this, no information is really destroyed but is stored in the event horizon in a highly scrambled form. Now, if the universe is like a hologram, then everything physical, including the time that we experience and see in the three-dimensional world, is just a projection of this two-dimensional information. Just as we can perceive depth and movement in a movie on a two-dimensional surface, our own TV screen, we can perceive the three-dimensional universe as we currently experience it, even if it is fundamentally two-dimensional according to the holographic principle. This means, essentially in the physical world, everything you see and experience is only a detailed perceived illusion. However, it's important to note that the universe is much more complex than a movie on a TV screen, and our understanding of the holographic principle and its implications for the nature of the universe is still highly speculative and the subject of ongoing research. So, is the universe really a hologram? Well, the idea is still just a theory, and there's a lot of debate among scientists about whether or not it's true. But it's a fascinating concept that can lead to breakthroughs in pushing the boundaries of our understanding of the universe and challenging our perception of reality and illusions. And that's all we have time for today. Thanks for watching, and don't forget to like, share, and subscribe to our channel for more fascinating, mind-bending videos like this one.